Okay. Okay. So everyone can, okay. I didn't hear you, Amanda, so that's why I didn't. Okay. Let me get this started. Wait. Amanda, don't you want to share the deck?
Yes, I didn't know if you wanted to introduce yourself and kick us off.
Oh, you can just share the deck and then well, let me
Okay.
just say my name is Marie. I'm a tutor for Leland. I've been working for Leland for 3 or 4 years. I can't remember where I officially started. I've been doing GMAT, GRE for, well, 8 years full time, and I did it a long time before that too. But I've been a tutor, SAT, prep tutor, and LSAT too, which I don't like to do anymore. But I've been tutoring for 20 years now. And I was also a high school teacher in math, and I got my master's in math education at Columbia. And I think that like really informed a lot of how I teach test prep. And this is really my favorite thing to do. And I'm glad to do it full time now. Okay. You can share the deck and then I'll take over.
That's it. We've got it. We've got it up, and I've dropped your profile in the chat. So I'm going to go ahead and stop screen sharing, and you can take over with the meat of the content today.
Oh, okay. Okay. Great. Okay. Okay. Here we go. Okay. Okay. So this is a lesson on integer properties, which I'm going to introduce you to the idea of number caterpillars. But I'm going to start by asking everyone, hopefully you guys have paper because this is a real lesson. And I mean, I guess if you don't, just watch. But what I would like everyone to do is start by writing the first 10 prime numbers, not the prime numbers under 10, but the first 10. I'll give you guys a minute to do that. And I really do like if you guys can interact. So if you can, I don't know, in the chat, just say done when you're done. And it helps me because I'm not used to always having to avoid, and it's always a little bit I never know how to paste these things. But yeah. If you want to type the prime numbers, be my guest. Or just type done when you want me to say the next thing. Okay, cool. I've got a couple done. I'm going to keep going. Okay, first prime number is 2. Sometimes I joke and say like it's a celebrity prime number because it's the only even. And later on in later lessons, when I talk about odds and evens, I call it the contaminant. But 2, 3, 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. These are the first 10. And first, I'm going to start off also by explaining why 1 doesn't count as a prime number. Okay. So the way I liken prime numbers to elements on the periodic table, when we learn about molecules, like when we think about H2O, okay, a water molecule, we learn that that's an oxygen and 2 hydrogens. And elements or prime numbers are like the building blocks of all integers. So like 12 is a molecule. When you think about when you break down 12, that's 2 times 6, 2 times 3. So we know that 12 is 2 times 2 times 3. And when I first started teaching many years ago, when I was teaching SAT, I used to call them number molecules. I went through before I became a high school teacher, I was a middle school teacher, and it changed to number caterpillars. I mean, my middle school students like this idea a little bit more. So ever since it's become number caterpillars, the idea is like I would, do them like this. So although that this concept, I mean, I make it look really, I try to use these like sort of infantile things, it's extremely difficult. So I just feel like it's a little bit easier to grasp. Okay, so what I'm saying is that a 12 has 2 2s and a 3. And the reason, and it's unique, that 12 has 2 2s and a 3, and 2 times 2 times 3 equals 12. And that's the only way it goes. If I put a 1 on this and another 1 and a 1, it would still be 12. That's why 1 isn't a building block number and 1 isn't a prime number. In some ways, it's like what you have when you have no prime numbers. Okay, so that's when I talk about number caterpillars, and later on, this is going to be a big theme. So, number caterpillars, I also say, like, if I were talking to a math teacher, I would just be like, it's just the prime factorization. I'm just really like talking about the prime factorization of a number. So, take a second to do the prime factorization of 18 and the prime factorization of 30. You don't have to put legs or anything on this. And then I'm going to do this as well, and I'm going to do this color coding thing. You can do factor trees if you'd like, but my students eventually start seeing this a little bit faster. Okay, and then I am going to color code them so I can explain the next part. And all the twos, I make the same color. All the threes are going to be the same color. And all the five, well, there's only one five, so that's that. Okay, so one of the first assignments, after I explain this whole concept and I do my first lesson with students, I'm not going to get into everything I do with my first lesson because it's pretty hard, and I always have to, I adapt it to each student, and I have to see how students respond to it. But my first, after, this is something that one of my students did on her iPad, and I've kept it. And the student got into Harvard. So she's going to Harvard in a couple of years. She got in deferred. So, but this was like the first, this is a homework assignment between my first and my second lesson. There's other things that I'm going to explain today that would make this easier to do, but doing the prime factorization of every number between 2 and 100 and see how there's no one here. And the first 100 numbers, you do have to get to know a little bit better than you need to know them well, like, you know, like knowing that some of these are the longest, like 64 is 2 to the 6th power. This is 2 to the 5th times 3. But that's an assignment that I have people do because, I mean, recently I had a student who said something like, they're really everywhere. Number caterpillars are everywhere. And I'm like, yeah. And so this is why this is always my first lesson. Okay, so first I'm just going to go over. Okay, yeah, the recording. So I'm going to go over some other things. Just the idea of what the greatest common factor and the lowest, well, hold on, let me get over here first. Let's just go over the concept of what a factor is. Okay, factors fit inside. Factors are finite. Okay, I'm just trying to use a little alliteration to factors fit inside. So I always tell people, like, start off with the outside inside method. 1 and 12, 1 times 12, 2 times 6, 3 times 4. There are 6 unique positive factors of 12. Over here, this is the prime factorization. I would never say that there are 3 factors of 12. The caterpillar sometimes helps you, and I'm going to show you that in a second with harder numbers, but I just wanted to do 12 to illustrate something. Multiples are infinite. Definition of a multiple is 12 times an integer. So technically 0 is a multiple of 12, but I'm going to start with 12, 24, 36, 48, 60. And this goes on forever. Okay. And before I get to greatest common factor and lowest common multiple, I want to just sort of establish some things that you'd be comfortable with before I start getting a little bit, you know, like a little bit more complicated. So multiples of 12, every multiple of 12. This is 2 times 2 times 3. This is 2 times 2 times 3 times 2. This is 2 times 2 times 3 times 3. 2 times 2 times 3 times 2 times 2, and 2 times 2 times 3 times 5. And what I'm trying to illustrate is to be a multiple of 12, you need to have the pieces of 12 inside the caterpillar. I will come back to this later, okay, when I know it usually gets a little bit confusing. So the greatest common factor, lowest common multiple. Let's review what these terms mean. The greatest common factor just means the greatest common fits inside. I think the problem is sometimes people think greatest and they think the number is very big, but the greatest common factor of these 3 numbers of 4, 8, and 48 is 4. And the lowest common multiple of these three numbers is 48, because this is the smallest number or the lowest number that they all fit inside. Okay, so I just want to say that the greatest common factor pushes that way. The lowest common multiple pushes that way. They're squeezed side. Or look, you could just say that that's one. I mean, it could be infinity. 48 million, for example, 48 trillion. So we don't find the, those, okay? Okay, so this is a way that I was taught to do this. I was taught this in 7th grade, sort of, and it stuck with me. And that's why, I taught this in middle school 30. So again, I'm looking for what's common in all of them, what fits inside all of them. And I see that they all have a 2 and they all have a single 3. And I'm gonna erase that so I can use this later. So I know that they both have a 2 and a 3. I would also say, if this one had an extra 3, and I would have put 2 3s on this chain. I'm just saying, because later on, sometimes people don't realize that I can double up on the same prime number, and you can have, like a bunch of 2s, a bunch of 3s in your greatest common factor. But right now, the greatest common factor of 12, 18, and 30 is equal to 6. And okay, lowest common multiple, this is a little bit more about what I was doing over here. The lowest common multiple of 12, 18, and 30. Sometimes I say it's like the mama caterpillar. There's so many different ways to teach this that sometimes when I'm teaching a single student, if this doesn't click, I'll teach it another way and another way until, I feel like we can move on to the next thing. So just bear with me here. When I'm looking at this, I'm basically trying to say this number that I'm creating has to fit all of these pieces. It has to fit all of the pieces, or it has to be able to say that 12 is inside, 18 is inside, or 30 is inside. And it has to, but it's like, again, why I call it the mama caterpillar, or sometimes I'm like, it's like a kangaroo putting the kids in her papoose or whatever like that. But she wants to make sure that she holds all these numbers, but she doesn't hold. So looking to illustrate that, am I going out in and out for everybody?
Marie, I'd say for the last, so your internet connection has been going in and out a bit.
Oh, okay. I don't know. I don't know if I should leave and come back. I had 2 lessons today. I didn't hear anything. I don't know if it's because I have, you know what? It's because I don't know if it's.
Sometimes if you turn off your camera, it's a little bit more stable. I wonder if that'll make a difference.
Okay, let me try that and let me know. That's so annoying. I'm so sorry. Okay. I don't know if it's because I haven't experimented with where I am, and is it any better?
So far.
So far, so good?
Yeah.
Okay, okay, you guys let me know. It's annoying if that happens. Okay, so, okay, back to what I was saying was that the mama caterpillar needs to be able to fit all of these in her papoose. So you're building a number, and to make sure that 12 goes into it, I would need to have 2 2s and a 3. To make sure 18 goes into it, I need to have 1 2, which I already have, and 2 3s. I have 1 3, but I need to add a 3. Okay, so right now the number, let's just take a beat here, is 4 times 9, or 36. And this number is definitely divisible by both 12 and 18, right? 12 times 3, 18 times 2. It's not divisible by 30 yet, because 30 requires that you have 1 2, 1 3. Those are taken care of, but you also need a 5. Okay, so instead of, well, just doing 36 times 5, what I usually do is tell people, these 2 tests, GRE and GMAT, really both stress a lot about how our numerical system isn't a base 10 system. So you should always look for 2 times 5 in your, if in anything that you're multiplying, but that's 10. And then I would say this is, you know, I know this is 18. So the lowest common multiple is 180. Okay, 18 times 10. Okay. I'm going to give you guys harder numbers to work with in a second, but right now I'm going to go to another thing. Okay, so first off, let's say I asked you to find all the factors of 180. Okay, so whenever I always say like buzzwords, for number caterpillars. And really, I've kind of changed it to not just saying number caterpillars, but like for factoring in general. My students, I say factoring is my favorite word, okay? Not distributing, not multiplying, factoring, because it's always really about breaking things apart. And this whole idea is like, it is important to understand that sometimes I don't really care if the number is 63. I just can look at it 3 times 3 times 7, and this is what I'm going to use, because that's how I'm going to pull apart and divide and do a lot of different things. It changes the way you think. The first lesson really does change the way you start looking at numbers. But buzzwords for number caterpillars and factoring. Factor, divisor, divisible, multiple. Usually things that have to do with primes, integers. A lot of things where that ask you like an integer squared. Okay, so are we still good? Because I did get a thing that said my internet is unstable. Just let me know. Okay, so find all the factors of 180. So first of all, the prime factor of 180 is 2 times 2 times 3 times 3. Wait here, you know what? Let me just do it. I'd say like, look, let's pretend I didn't just see this number, but it's 18 times 10. So I'm like 2 times 3 times 3 times, that's 18 times 10. This is sort of how I do numbers more quickly when I'm trying to break them down in my head without a factor tree. So starting with 1 and 180, and then 2 goes into it 90 times. 3 goes into 18 6 times. So this one, 3 goes into it 60 times. At this point, I go, does 4 go into this number? And if you were on video, if we were on video, I would be able to tell if you were doing division or what you were doing, because usually people tilt their head to the right and look up, or maybe the left, I don't know. But people tilt their head and do division, okay? And what I'm trying to say is, okay, so like sometimes, you know, take a minute to think, and they're like, okay, 4 goes into 100 this many times and 80 this time, and then they finally give me the answer. But that's not how I do it. I think of like 4, the caterpillar for 4 is 2 times 2. And I see it right here, 2 times 2. So yeah, I know 4 goes into it. And 4 goes into it 3 times 3 times 5 times. And so 9 times 5, 45 times. Okay, so instead of doing division, I multiply upwards. And then this is how I explain. Let's just do here. I have to put some other ones up. 7, 11, and 13. And let me give these some different colors. 7's a prime, 11's a prime, and 13 is, let's make it that color. Okay, so 5 goes into it. 5 goes into it 6 times 6 times, so 36 times. I'm going to mention that one thing that sometimes students do is I call it climbing, where they go 2 times 3 is 6. 6 times 3 is 18. 18 times 2 is 36. And instead of that, you should really try to break things down the way I did, like 6 times 6, or I don't know, something smaller than 1 at a time, because that takes forever. Okay, 6 goes into 18 3 times, so 6 goes into 180 30 times. 7 7 does not go in because I look here and I don't, 7's a prime number. It is like an indestructible element and it's not represented here. There's no way you're going to, multiply anything to be 7. So that's why 7 does not go in. Next one, 8. I ask people if 8 goes in, and usually people say no because they see that it cannot multiply to be 8, but also because 8 is 2 times 2 times 2. So 8 needs 3 2s. And it's a different reason, so I just want to distinguish that, okay? It's a different reason. We don't have enough 2s. But 180 times 2 is definitely divisible by 8, okay? That would, be 2 times 3 times 3 times 2 times 5 times 2. And I know it would be divisible by 8. And it'd be divisible by 8 45 times, okay? So 360 degrees, divided by 8 is 45 degrees. Okay, so 7 doesn't go in, 8 doesn't go in. Obviously 9 goes in. You see 3 times 3 right there. And you know that 9 goes into 18, so 9 times 20. 10 goes into it 18 times. 11 doesn't go in for the same reason that 7 doesn't go in, because it's that color's not there and it's prime. 12, and we just, 12 is 2 times 2 times 3. 2 times 2 times 3, and 12 goes in 15 times. And then 13 doesn't go in because I don't see that color. 14 doesn't go in because 14 needs a 7. And we're done. We've closed the gap and we have all the positive factors of 180. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 times 2. There are 18 positive, unique factors of 180. Usually in my lessons, sometimes I teach another way to find how many factors are in a number. It's kind of a complicated topic, so I would never really have done it in one of these intros. But first, let's just take a little practice. This is what I would usually do right here. And I'm going to ask you guys to, I'm going to erase all this. I'm going to ask you guys to find the greatest common factor and the lowest common multiple of these 3 numbers, 72, 96, and 60. And if you have no idea what to do, at least start by just caterpillaring the number, finding the prime factorization of each, and then, watch as we do it. When some people think that they have it, just say done. When they have either the greatest common factor or the lowest common multiple, and then we'll go from there. If you guys are either struggling or if anyone's has any comments, there's not that many people in this recording here. Please, make your, let me know if you have any questions. You can either direct them straight to me or put them in the group chat.
Hi, yes, this is Marcus. I just had I'm kind of confused between the difference between the factor and the multiple. Like,
I'll start by giving a little hint that the factor, well, the factor has to be a number that fits into all of them. So it has to be less than 60. I always tell people, it's, to give you a hint, it's less than 50. The lowest common multiple is a number that they all fit into. It's bigger than 1,000. It's less than 2,000.
oh, and we're trying to find the greatest common multiple too.
No, no, no. There is no such thing as a greatest common multiple because that would be infinity.
Right.
Okay. But we are trying to find the greatest number that fits into all of them. Like, let's just pretend here. Maybe if I rephrased it like this and I said 72x plus 96y plus 60z. And I said, factor out the greatest common factor. That's what we're looking for. Okay. Factor out the greatest common factor. In another way, like I used to teach trigonometry, and when my students there was sometimes when I had to, if they had something like this, and when you add and subtract fractions, you need a common denominator. My students, if this was like in my trigger calc class, at that point, I do let them use calculators. But before that, I never do because, they need to learn how to think better. But they would struggle with they would just multiply 72 times 96 times 60 to get a common denominator instead of finding the lowest common denominator. So when you do 72 times 96 times 60, you get a ginormous number. At the end of the day, then they have to reduce everything. And I used to say, like, I only have one answer key, and I'm not going to try to figure out if your number is correct, compared to mine. You have to get it down to its lowest form. So that's what that we're doing. In this case, we're trying to find what number that I would pull out of all of them. And this one, we're trying to find what's the smallest denominator. Like if I had to get the common denominator, what that number would be. Does that help? Put it in perspective, maybe? I mean, I'm just trying to remind you about what like high school would look like, but it's not so much what you're going to see on this test. This leads to like the hardest topics on the test.
Yes, this is helpful.
Okay.
Thank you.
You're welcome. Do you want me to keep going? If you guys want me to keep going, just keep going. Just want to make sure you're still in here. I need to make sure. I need some like reassurance. Okay, thank you. I appreciate that, Marcus. Okay, keep going. Okay, so 72. 72 is 2 times 2 times 2 times 3 times 3. 96 is 2 times 2 times 2 times 2 times 2 times 3. And 60 has 2 2s, 1 3, and 1 5. This is the caterpillar for all of them. So when I'm looking for the greatest common factor, I'm looking for what I see in all of them. And I see that they all have 2 2s because 60 has the least amount of 2s. So they all have 2 2s. And then look at 3s. Do they all have 1 3? Yeah, 60 has 1 3, 96 is 1 3, 72 has 2, but they all have 1. And do they all have a 5? No. So basically, this is the greatest common factor, 12. Okay? 12 is the greatest common factor. And if I had to do that, I would pull out the 12. And if I pulled out the 12, just watch, then I'm going to erase this stuff later. But if I pulled out the 12 here, I would have 6x. And then I would pull out the 12 here, and I would have 8y. And I pull out the 12 here, and I would have 5z. That's what that's about, okay? So back to, now let's say that I wanted the lowest common denominator, okay? What I need, looking at this is the mama caterpillar, okay? So going back here, I'm going to change this to exponential form. This is 2 to the 3rd. This is 3 squared. This is 2 to the 5th power. This is 3 to the 1st. This is 2 squared, 3 to the 1st, 5 to the 1st. Sometimes people like it like this, but I like the visual of seeing them all because sometimes this analogy of calling it a caterpillar changes. And then later on, I start talking about, like if I was talking about 100 factorial, I'm talking about all of these beads, all of these being strung together. So I'm like, it's 2 times 2 times 5 times 5 times 3 times 3 times 11. And 100 factorial, I mean, I can, put it up on the screen for you, but it is a ginormous number. Okay. And sometimes you're going to be asked things like, how many zeros are at the very end of 100 factorial? And, there's 24. And that lesson usually comes second after I explain, this is my first lesson, but we do a little bit more of that on the second lesson. So you can start understanding factorials. But 100 factorial means literally a caterpillar that would have every single bead on this page, on a giant string, like a giant beaded necklace. Okay. So back here, if I want this mama caterpillar, if it's going to fit here's another way to look at it. If it's going to fit 96, this mama caterpillar has to have at least 5 2s because 96 has the most 2s. So what I could do is look at the number. Look, all I have are 2s, I have 3s, and I have 5s. Okay. I need to have 5 2s for 96 to fit in because that has the most number of 2s. What has the most number of 3s? 72. I would need to put 2 3s on it so 72 can fit. And 60, the 2s are covered, the 3s are covered. I need a 5. Okay, so this is what I need. 2 to the 5th, 3 squared, 5. I would take a 2 times a 5 first and just say that's 10, cross that off. And then I would look here, 2 to the 4th power is 16. This is 9. So I have 16 times 9 times 10. Okay, that's what I'm looking for. Now, 16 times 9, I would say 9 times, here, let me just show you how I do this, but I would go 9 times 10 is 90. 9 times 6 is 54. I add those together. I have 144. So my final answer, the lowest common multiple is 1440. And that's what I'm saying here, that the lowest common denominator between all of these. Now, okay, if you're not going to have a problem like this, but I still want to use this as an analogy because this is like strong, like building your skills here. 72, to get 72, look at what we had here. Okay, we need our number 1440. Let me just write this again. 1440 is 2 to the 5th power, 3 to the 2nd power, 5 to the 1st power. If I were to multiply, I want, what am I need to multiply 72 by? So 72 needs to have, to get here, 72 needs 2 more 2s. And it needs no more 3s. It's good on 3s, and it needs a 5. 2 times 2 times 5 is 20. So I'm doing 20 over 20. So it would be 20x. Okay. 96. What does 96 need? It doesn't need any 5s. It does need 1 3. It does need 1 5. So what I'm saying is 96 times 15 gives me 1440. So this would be plus 15y. And 60. What does 60 need? 60 needs, it needs 3 2s to make 5. It needs 1 3. So 2 to the 3rd power is 8. 8 times 3 is 24. Okay. In an ideal world, this is what, my trig students would be able to do more easily to get to this. Again, this is more like what my trig and my calc students had to deal with. This is not totally test prep, but obviously it's like related because this is what's going, there's a different, way to how this is going to approach. Okay. Anyway, let's move on to the next topic, unless anyone has any questions. If you do, please put them up now. The next thing we're going to go through are the rules of divisibility. I always do this on the first day because, again, and not to, I do talk a lot about, but this is another thing that I did learn in 7th grade and it stuck with me. And I always feel like I was very fortunate to go to a school that never let me use a calculator until I got to trigonometry, because for that reason, I always kept these things it's just, I always remember these things and feeling like rules of divisibility to me are as important as learning your multiplication tables. So, okay, so just so you know what I'm talking about, let's start off with like the rule for 2. You know that 2 goes into a number if the number is even. You know that 5 goes into a number if the number ends in 0 or 5. Okay, those are the ones that I think are pretty easy. Hopefully, I'm not going to write the 10 rule, but you know that 10 goes into a number if the number ends in 0. Okay, the most important rule really is the 3 rule. Okay, the rule for 3 is that the sum of the digits is divisible by 3. Okay, so the reason that this is the most important rule is, first of all, I want to illustrate. If you look at the caterpillar, I hate that. Okay, if you look at the caterpillar, 3 is in every third number. Okay, 3, 6, 9, 12, 15, 18, she forgot, 21, 24. Okay, so you have a 33% chance, 33.3% chance that your number is going to be divisible by 3. So it's pretty high probability. And it's good for what I call the weird looking odd numbers. Some of them, here's a good question for this. How many numbers, or how many integers, I should say. How many integers between 40 and, wait, hold on, 50 and 70. How many integers between 50 and 70 are prime? Okay. So first thing I'm going to do is I'm just going to write out odd numbers, because every prime number is odd except for 2, and 2 doesn't fall within this range, so I don't have to worry about that. So 51, 53, 55, 57, 59, 61, 63, 65, 67, and 69. Okay, so first let's cross off the obvious ones. We already know that anything that ends in a 5 is not prime. So I'm going to cross off this and cross off this. When I say weird looking, I don't know what level of multiplication, but hopefully you look at 63 and you know that that one is 7 times 9, 9 times 7. But either way, it doesn't matter, because the rest I could just use the 3 trick. Like, here's the idea. 6 plus 3 is 9. 9 is divisible by 3. So therefore 63 is divisible by 3, because it's divisible, it's divisible by 9. So it's divisible by 3 twice, or 2 3s, I should say. Same difference. Okay, the other ones I can call them all, I'm going to call the rest of them weird looking odd numbers, meaning like, I don't know, I think they're prime because I don't know any of them offhand. But this is where the 3 trick comes from really handy. 5 plus 1 is 6. And therefore 6 is divisible by 3. That's not a prime number. Okay, we'll look at 51 in a minute because I want to show you how to do long division better. 5 plus 3 is 8. 8 is not divisible by 3. That is a prime number. 5 plus 7 is 12. 12 is divisible by 3, not prime. Okay. 5 plus 9 is 14. 14 is not divisible by 3. Therefore, that's prime. 6 plus 1 is 7. 7's not divisible by 3. That's prime. 6 plus 7 is 13. 13 is not divisible by 3. That's prime. 6 plus 9 is 15. 15 is divisible by 3. Therefore, these are not prime. So all these 3 numbers are not prime number. They're not prime. They are divisible. They're all divisible by 3. And I'm going to show you a little bit long division the way I do that. But there are 4 integers between 50 and 70. Now, the 3 trick doesn't work for every single number in the world, but it does work for every number under 100. You do have, when I say it does work for every number, like 49 is what I would call hopefully you know that this one's 7 times 7, okay? Or 77, you would know that that's 7 times 11 because you know the 11 trick. But if you know your multiplication tables pretty reasonably, and you're worried about, it helps you with all the other ones, okay? And what the deal is, there's only one number that it doesn't work for. I always tell my students just to memorize this one. I say, this is my favorite number. Don't forget it. 91, okay? 91 is 7 times 13. It's the lucky times the unlucky, but 91 is the exception. And I make a big deal about this because tests love 91, okay? They don't bother you so much. These tests are not going to really go crazy about numbers that are over 100. They're not, it's really like understanding all these rules for the numbers under 100. Okay, looking at 51, I want to show something I didn't introduce before, but I had to show you when I was doing 9 times 16. I wanted to show you how I do 2 by 2 multiplication. So if I had, say, a number like 21 times 13, I do this box method. And I use this box for a lot of different things, for how to factor. So I make my students do this. So I would say 21, there's 20 plus 1, and then 10 plus 3. And then I go 10 times 20 is 200, 10 times 1 is 10, 20 times 3 is 60, and 3 times 1 is 3. And I do this one because I think it's a lot easier than, like, I don't like any of that carrying stuff. And I can just see that it's 273. Okay. Or sometimes I might have to actually like stack it up, but it's much easier to do. The other thing it really illustrates is it drives home the idea that a units digit times a units digit of a number, that this number has to end in a 3, because you see how these end in zeros and zeros and zeros. The units digit of a number will come from the units digit of a units digit. Even if I had something like 17 and 23, this would be 21, 140, 230, and the number will still end in a 1. 7 times 3 is 21. The number ends in a 1. That's the point that I'm making. Okay, it's just that helps with that. So 2 by 2 multiplication is something I cover the first day. Another thing I do is now this long division. When I do long division, 51, and now I know it's divisible by 3. I don't really put much up here, but or anything. I do this way that I don't know. This is sort of, I would say that I always did this myself. And then when in grad school, I learned how to, a teacher who taught, he was the one at Teachers College who taught all the elementary teachers. And he showed us like methods that he used to teach middle school teachers how to teach math better, and elementary school teachers how to do division. And one way they do it is, well, here, I'll show you. So instead of saying like 3 goes into 5, the old way, you kind of just go like this and you put a 1 here. The big difference is I'm just going 30. Okay, I know that 3 goes into 51 at least 10 times. Okay, to make 30. 3 times 10 is 30. And then subtract. And then 3 goes into 21 perfectly. It goes in 7 times. So 51 is 3 times 17. Okay, and that's why you don't know that one, because it's, no one really knows there are 3 times tables up to 17. So there you go. That's the caterpillar for 51. 57, same thing. You put a 3. I would go start with 30, 27. Now I'll just show you why I like this way more, because let's say you just, I don't know, blank on how many times 3 goes into 27, but you're like, well, I know 3 goes into 15, and it goes in 5 times. Then you could subtract, and you just have to do the subtraction correctly. And then you're like, oh, 3 goes in 12. I know that one. It goes in 4 times. So you did it in 3 steps instead of 2, but the answer is still the same. It's 19. So 57 is 3 times 19. Those are both prime numbers. That's its caterpillar. And 69, I'm going to skip this one, but it's just 3 times 23. It's another one that maybe it's easier to see because you can see that 3 goes into 6 and 3 goes into 9. But what's going on is, hopefully you're seeing this pattern, but the weird ones are 3 times 17 and 3 times 19 and 3 times 23 and 3 times 29 and 3 times 31. This one gets you to 93. 3 times 37 is outside the 100 range. So I'm glad you like that. The 2 by 2. Good. Okay. But a lot of it, this is everything. I feel like I really have to retrain people how to think about arithmetic. So, okay, we're building up to a good problem, I promise. Okay, so the 9 trick. The 9 trick is the same thing as the 3 trick. It should be because 9 is so closely related to 3, but the sum of the digits is divisible by 9. Okay, this is important. Hint, hint, this is important. Okay, we'll come up. And let's see, the 4 trick. Which number is an exception to the rule of 3? 91, this one. This is, I'm saying for all the numbers under 100. I mean, there are other numbers, okay? And that's usually my second lesson. But I talk to my students and I talk about what I call the edges of the universe, as far as like what I say is like, that's beyond the edges of the universe. Like, you don't need to know what 7 to the 4th power is, but you do need to know 2 to the 1st power up to 2 to the 10th. You need to know 3 to the 1st power up to 3 to the 5th. You need to know, it would be helpful to know 4s, but 4s are really just a version of 2s, and you need to know 5s. But here's another thing. I tell my students, especially GRE students who always want to do things with a calculator. First of all, you never need to use a calculator. And usually I tell people, do not ever use a calculator. Let me know every time you feel like you need to. But I always say, like, your fat fingers get in the way. How many times have you ever typed in a Wi-Fi password and you type it in incorrectly? Okay, that's the whole point. Well, hold on, let me just say this. First, let me finish my calculator thing. How many times have you typed in a Wi-Fi password and it's been incorrect? So you should not be using the calculator on the GRE. This is obviously a much easier sell to my GMAT students who don't get to use a calculator on the quant section, but they will listen a lot more about, because every single time they're like, how am I supposed to do this with a calculator? I can show them. Yeah, Mamina, what I'm saying is 91 is an exception, because 91, if you just use the 3 trick, you would think, oh my gosh, 9 plus 1 is 10. And that is not a multiple of 3. Therefore, it must be a prime number. And what I'm telling you is it's not a prime number. It's 7 times 13. And I just make people, because I'm never going to teach you a trick for 7. And I'm not going to teach you a trick for 13. Are there tricks for them? Probably. They're just, I know the trick for 7. I just don't use it. And I use it because I don't use it and I don't teach it because it's really outside the edges of the universe. It's not a good trick. 13, I've never learned a trick, but there's a trick for literally every single integer. It could be super crazy and weird, but there's always some sort of algorithm for any integer. There's going to be a rule. Okay, so 4. These are inside the edges of the universe. So these are things that all my students need to know. Okay, so this, I sometimes make a little joke and say, this one's magic. I don't know why it works, but it does. Or, I'm not going to go into the proof. But 4, the trick for 4 is a little bit more logical. First, let me say what it is. The last 2 digits of the number of the integer are divisible by 4. Okay, or a multiple of 4, whichever way, or a multiple of 4, it's the same thing. But let me explain. 2,732. This number is divisible by 4. And I'm not adding that. This is not like the 3 and the 9 trick. Okay, I'm just saying the last 2 digits, 32. Not 3 plus 2, not 3 by itself, not 2 by itself. 32 is divisible by 4. And therefore, I know that 2,732 is divisible by 4. And now I'm going to explain why it works. 4 is a number. We know that 100 is divisible by 4. Okay, hopefully that 100 is divisible by 4 25 times. So if you know that, then you can take this number or any number and change it to a multiple of 100 plus the leftovers. And you would know if 4 goes into 100, then 4 goes into 200, then 4 goes into 2,700. So 4 goes into any number or any multiple of 100. And you just got to look at the leftovers and see if 4 goes into 32. And that's why this trick works. Okay, that the last two digits of the integer are divisible by 4. Okay, this is important. So hint, hint for what's coming up. The next one is I teach is 6. 6 is not so much a new trick. I always feel like 6 is a little bit of a look. What you're doing with 6 is you're just saying, this is a caterpillar for 6, 2 times 3. So when I want to know if a number is divisible by 6, I want to know if the number has a 2 in it. Is the number even? And is the number divisible by 3? So for example, this number, 1002. It's even, so I know it's divisible by 2. When I add up all the digits, I get 3, so it's divisible by 3. Therefore, it's divisible by 6. And I'm going to do this long division again and show you how I do this. Okay, back to the old way, because I know that this is definitely the stuff that's a little bit harder to get used to. And I had students who'd use the old way until like lesson 5. And then by the time they see me do it so much, they're like, okay, I finally realized why your way makes more sense. So I know it's a little bit hard in the beginning, but in the beginning you would go 1 and then you'd put a 6 down here. And all I'm really asking you to do is just go 600. Okay, just add 2 zeros and then say that's 100 times. And then do subtraction, 402. It's also really easy to subtract this way. And then I think of like, let's say, you know, I don't know, you get 402. Now you're doing this. You would probably just go 36. Now I'm just saying do 360, okay? And you would say, okay, 6 goes into 360, 60 times. I mean, you're saying this times this is this. This times this is this. Subtract 42. Now, again, let me tell you the appeal of this way. I know that, let's say you kind of forget that 6 times 7 is 42, but you know 6 times 5 is 30. And you go, okay, well, it goes in 5. I know for sure that 6 goes into 35 times. And you subtract. And you're like, oh, you know, and then you see here that it goes in 2 more times. See, I did it in 4 steps instead of 3. But whatever, this way, at least it comes out exactly the same. You know, now you're down at 0, so it's 167. Okay, so 1002 is 6 times 167. This is 2 times 3. And we don't know yet if 167 is prime, but I'm going to show you how to do that in a second. Okay, I skipped over the 8 trick because I have not used it in the last 4 or 5 years, but the 8 trick, I just have to pay lip service to it because when I do fraction to decimal, I always do. It's the last 3 digits. Okay, it's like the 4 trick, but you would see if the last 3 digits are divisible. Yada yada. Don't worry about it. I just feel like I have to. I'm a little bit like, you know, I just attention to detail on that, and I want to keep the symmetry. Okay, finally, let's see, 2, 5. Okay, so we've done 2, 3, 4, 5. 6, 7, and I'd never teach 7, 8, 9, 10. We all know 11. Now, I'm also going to say that I learned all of these tricks. I mean, if anyone's like, wow, but I did learn all of these except for 8 and 11. I learned these all in 7th grade and they stuck with me forever. And I mean, I don't, you know, they stuck with me because again, this is how I reduced every single fraction to make sure it was like in simplest form. But yeah, 11th grade, 11 and the 8 trick are a little bit above a 7th grader's pay grade. So, okay, the 11 trick is you alternate positive and negative signs on each digit. Okay, you alternate and then I'm sorry, and then you sum together and see if the result is a multiple of 11. And then I put like giant 0 counts. Okay, 0 counts as a multiple of 11. This is a big deal because it's pretty much like almost always 0. So here's an example. 143. So I'd go plus, minus, plus. And what I'm saying is you're going 1 minus 4 plus 3. Okay, so 4 minus 4 is 0. You get 0. So that's how you know that 143 is divisible by 11. And then I'll go 11 and I put an 11 here and a 0. And I'd say 11 goes into this number 10 times, subtract 33. 11 goes into 33 3 times. And now I have 143 is 11 times 13. And that's how I caterpillar that. Okay. So the 11 trick is not outside the edges of the universe. It happens a lot. And when I teach my first lesson, I can go a little bit faster because I'm sort of like going back and forth with a student. They see the number 91 a lot. They see the number 11 a lot, but they use the 11 trick a lot on these tests. Okay. They like to make multiples of 11 just because you can, okay? Just because you can. Also, when I teach people fraction to decimal equivalents and terminating decimals, every single number here gets represented. And I used to teach the 7 trick, but I took it off because I did realize it was kind of useless. And I also don't teach people fraction to decimal equivalents with 7ths. Like we don't do 1/7, not because there isn't a pattern, but just because it's a 6-digit repeater. So if you put in a calculator, like 1/7 is like 0.14, and then there's 4 more digits. It's whatever. It's a 6-digit repeater. And 1/11 is a lot easier to understand. Anyway, back to 1002. 1002 is 6 times 167. This is 2 times 3. So to figure out if 167 is prime, the first thing I would do is, you know what, I remember thinking like it's really close to 169. And 169 is 13 times 13. So if 167 is not prime, if it's not prime, it has to have at least one prime number that is under 13. What I mean is it couldn't, like prime numbers, it couldn't have, say, 17 times 23. That would be bigger than 13 times 13. So it has to have at least one underneath. I'm not saying it has to have both, but at least one. So the prime numbers under 13 are 2, 3, 5, 7, and 11. And you can look at 167, you know it's not divisible by 2. You know it's not divisible by 5. Use the 3 trick. 1 plus 6 plus 7 is 14. 14 is not divisible by 3. You use the 11 trick, plus, minus, plus, and you get 8 minus 6, which is equal to 2. And that's how you know it's not divisible by 11. And then you use this, well, there is no 7 trick. So I would just do long division and go 167. 7 goes into 140. This is 27. 7 does not go into 27. So 7 doesn't work. So if all of these don't work, then I know that this number is now a prime number. Okay, that's the logic I use for that. Okay. How are we doing? We're still here? Are you still here listening to me? Are we okay with this? Because I'm going to give a problem now. And it does relate to the rules of divisibility. Okay. I'm glad you guys are here. I'm glad I have an audience. Okay. So here's my problem. I hope you guys remember these. Okay. So, clean this up. Okay. Which of the following is divisible by 36? Okay. And hold on, let me get my numbers. Okay, here we go. 5,232. B. 5,742. C. 5,244. D. 5,364. And E. 5,130. Okay. So first thing, maybe I'm going to just talk through this problem. And if you want to try to do this problem while I'm talking, be my guest. I remember the first time I saw this problem, or it was similar. I think I modified it to make it a little bit harder. But the first time I did this problem, I saw that it said divisible. So right away, I totally know to use, I know that this is related to number caterpillars. And I saw 36, so I was like, I'll use the 6 trick. So I use the 6 trick and I'm like, wait a minute, they're all even. Okay, it's kind of like a bad sign here, but let me see what the sums of all of them are. So I added this up, 5 plus, I see 5 plus 5 plus 2, this is 12. This is 12 plus 6, 18. This is 15. This is 10 plus 8, so 18. And this is 9. And then I was like, okay, wait a minute. They're all divisible by 2, and they're all divisible by 3. So they're all divisible by 6, but the question didn't ask if they were divisible by, it doesn't ask which of the following is divisible by 6, because if you ask that question, then the answer would be all of them. And this, by the way, there's only one answer to this question. So then I thought about it a little harder and I was like, okay, well, what's 36? I mean, divisible, it tells me to think about the caterpillar. So, you know, this is 6 times 6, 2 times 3, 2 times 3. So 36 is 2 times 2 times 3 times 3, okay? And then I thought, why? And then sometimes I ask students, I go, well, why did you even pick 6 to begin with? And I think I'm leading to the question, like, we pick 6 because we know 6 goes into 36, which is true, but other things go into 36 too, okay? And I went through these rules, 2, 3, 4, 5, 6, 8, kind of, 9, 10, and 11. And if you use the 6 trick, you already used the 2 and the 3 trick. But I also gave you a trick for 4, and I gave you a trick for 9, okay? So the easier one is 4. Let's start with the 4 trick. Is 32 divisible by 4? Yes, I'm going to keep that. Is 42? No, okay? I got to get rid of B. 44 is divisible by 4, I'll keep it. 64 is divisible by 4, I'm going to keep it. 30 is not divisible by 4. 28 is 4 times 7, and then 4 times 8 is 32. Not divisible. So these are out, okay? I use the 4 trick. So the other trick is the 9 trick, okay? And that's why I summed all these things up here, okay? 9 does not go into 12, so that's out. 9 does not go into 15, but 9 goes into 18. So this is the answer, okay? Now, I can say from just what I know, just looking here, that the caterpillar for this number does have a 2 and a 2. I know it has at least 2 2s, but it has 1 3 max. It just doesn't have the second 3. If you ask me if this number is divisible by 12, I'd be able to do that. And let me say that again. So, or say it like in a different way. So if I want to find out if something is divisible by 36, I would like to use mutually exclusive tricks. Like the 6 tricks is not going to help me. But I could also ask, what's divisible by 18? And if I wanted to figure out what was divisible by 18, 18 is 2 times 3 times 3. So I would use the 9 trick and I would see if the number is even. And that's how I know a number is divisible by 18. So this one, for example, okay, if I use, this number is definitely even. It's not divisible by 2 2s. It just has 1 2 maximum, but it is divisible by 9. So this number is divisible by 18. Okay. This one has 1 3 maximum, and it has 2 4s, 2 2s at least, but I don't know if it has, you know, extra 2s. So this number, C, 5,244 is divisible by 12. A was divisible by 12, B was divisible by 18, and I think I made E divisible by 18 as well, because this has 2 3s and a 2. So they're all divisible by 12 or 18. Only this one is divisible by 2 3s and 2 2s, okay? That's kind of like how this could be used. 18, and then, I mean, again, everything that when you're doing these, the rules of divisibility help a lot for, like, if I wanted to figure out what's the remainder when this number 290 99, if what's the remainder when this thing is divided by 9? Guess what? It's 2. The remainder is 2. How do I know? Because 9 goes into 9 and 9 goes into 9, and there's 2 left over. Okay, because if the sum of the digits added up to a multiple of 9, then we'd be good. So I know that basically I know that 9 goes into 297. That's kind of what I'm saying, like the number that's 2 lower, because 2 plus 7 is 9 and 9. That's another thing. I don't always add them up. Here's another example. Here, hold on, let me look at this one. I always ask this. I go, what's the remainder? Just to show you. Here, we're done with this. Let me do this. What's the remainder when 237,941,386 is divided by 9, and then part B by 3. Okay, so hopefully you guys can all see this on your screen. What's the remainder when that is divided by 9 and by 3? So what I do, I usually let people do it, and what they do is they add up all the digits, and when they add up all the digits, if you do it right, you'll get 43. And then they go 43 divided by 9, 36, and then they subtract and they get 7, and the remainder 7. But I don't do it that way. I just cross them off 9 at a time. And I'm like, okay, 2 plus 7 is 9. That's 9. I mean, I'm up to 18 right now. 8 plus 1 is 9, 27. It doesn't really matter. I'm just crossing them off 9 at a time. 3 plus 6. And then I have a 4 and a 3 left over, so it's 7. And if I had to do this by 3, I could cross them off 9 at a time too and get to this point, and 3 goes into 7 twice, and it would be a remainder of 1. Okay, so these are like the little tricks I teach. There's so many little tricks. That's what kind of all this is about. And if I have to say something that I think all my students start realizing is that everything is about arithmetic. It is about making it, when your arithmetic is amazing, everything else falls into place. So building this base and having you guys understand like the fundamentals is kind of the big thing that I have to drive home. And I don't know, I made a game called Rapid Division that I make all my students play because I couldn't find a good app. So I spent like a crazy amount of money having some guy develop it, but I like it. It really has worked, and it's made a lot of my students who struggle with like the basics. It's just like a division that makes a game that makes people faster at seeing the patterns, and it works a lot with the caterpillars. And so, yeah, I think I don't want to keep it, I don't know how you guys are doing with, which verbiage. I think the question is like, what I'm saying is like anything that talks about divisibility, multiples, integers, but I have this thing where I talk about what my favorite strategies are. This is why
I just had a question real
Sure.
quick. If you can go back.
I don't think I can, but go ahead, ask the question.
I was just gonna say, because I thought the numbers added up to 42, not 43.
Okay, it was 2, 3, 7, 941, 386. Okay. Now 2 plus 7 is 9. That's 9. 6 plus 3 is 9. 8 plus 1 is 9. I have 4 times 9.
I see. Okay.
36 plus 4 plus 3 is 43. Okay.
Oh, you're not just adding up the numbers.
Well, what do you mean? If you add up the digits, if you added up each digit individually, you will get 43. But I'm saying that my way of doing it is I don't actually ever add them all up. I just knock them off 9 at a time. And I see that there's a 3 and a 4 left over. So it's 7 bigger than a multiple of 9. 43, if you do 43, you will go 43 divided by 9 has a remainder of 7. It does work this way. But I don't know. When I was taught this when I was younger, I was like, I'm not going to add these numbers up to, it just seems like more work, right? Like I just want to knock them off 9 at a time. I got 7 left over. Yeah, I don't know. I mean, again, I'm going, I do feel like I thought this was a cool, the question, how do I do it quickly for 3? You can knock them off 9 at a time too. Oh, you could knock them off 6 at a time. You could knock them off 12 at a time. It doesn't matter, but like I wouldn't, it's the same thing. I would knock them off 9 at a time and then see I have 7 left over. You know, the reason I say 9 is because look, just for this specific number, I noticed a lot of times you could just get digits that add up to 9. So if it was really long like this, it's smarter to knock them off 9 at a time than actually add them all up. But there are questions that you will see that say things like, well, I think I already said it, but like, you know, what was the one I used? Like if I had 929 and said, what's the remainder when this thing is divided by 9? The remainder is 2. Okay, I don't have to go much further. It is 900 plus 20 plus 9. I know 9 goes into this and 9 goes into this. And 9 does not go into this, but 18, you know, remainder 2. There, I proved it. Okay, but it's just a faster way because there's a lot of problems. Well, remainders are complicated, but there are problems that sometimes say things like, if X is equal to 929 and Y is equal to 969. Is this going to be good enough? Okay. What's the remainder when X times Y? Okay. What's the remainder? Let me put this lower. So what's the remainder when X times Y is divided by 9? And the number one thing I tell my students, oh gosh, I have to say that remainders have nothing to do with number caterpillars. So we have to use the old school setup and I don't want this turned into a fraction bar. This is not the way to go when you hear the word remainder. So what you do is you go, what's the remainder when X is divided by 9? 2. What's the remainder when Y is divided by 9? 6. And then you multiply 2 times 6 and you get 12. And then you go, what's the remainder when 12 is divided by 9? And it is 3. Okay, so that's the answer to that question. Okay, 3. If you did 929 times 969 and actually divided that by 9, the remainder would be 3. That's the faster way. Okay. Okay, so back to, I just want to say that this is something that I started realizing my students, I don't know, I go through these strategies. There's this, I'm going to start wrapping this up. Okay, I'm going to just talk a little bit about like what I do, specifically a little bit more so you guys can get an idea for what tutoring looks like, at least if you were a student of mine. Everyone does, you know, their different thing, but I think I'm like really a tutor for someone who's like, I want a massive change and a massive rehaul of my score, or not even. I mean, a lot of times I get people who, you know, might be stuck at, I don't know, a 158, 159, and they're trying to get to a 163 to a 165 if it's GRE. I still think in classic numbers a lot for the GMAT because for the past 8 or 9 months, I've been doing a lot more GRE and a lot less GMAT focus because there are a lot of unknowns with the GMAT focus. And usually that, you know, I talk about that with my students, but in the first session, like in an intro call, and we talk about which test. Amanda's putting up, you can put something to visit me, like to talk to me privately for a 15-minute thing, which I'm going to say usually turns to 30 minutes. So just beware. But the GRE and the GMAT are, they both changed a lot in the last 2 years, and there's a lot more unknowns with the new GMAT focus. So, and I will just also, you know, say that like, you know, because a lot of people are like, isn't the GMAT better? And every single one of my students is applying to M7, Stanford or Harvard only. I mean, you know, it's pretty, so you know, let me just like get rid of that myth, okay? That both of these tests will get you into any school you want. And they're not going to look down on you for taking one test over the other. So one thing, you know, this is how I organize my students. I will show you some of this stuff. Every single one of my students here, I put the template up, but you know, so I don't put last names because sometimes I want to share how other people are doing so people can see like what worked. And first thing I do, this is sort of like what I do in my intro call. I take, you know, your background information when you're applying, if you've ever had scores, if you've done prep, where you're, you know, going, and then obviously like just time zone for certain things. And sometimes your schedule, because I do also talk a little bit, like I help people actually manage their time. There's some people here, I could think about this student right here, Emma, and she like lives in London and she has to travel to Sweden once a week. And, I'm like, we literally started talking about like when she's going to do her work, because I'm not here to badger you. I mean, you guys are adults paying for expensive tutoring. So I'm a big part of like trying to make this as efficient as possible. And then my lesson notes, this is just sort of a typical thing. This is something that was a little, so my lesson notes, you can kind of see like, this is someone who I met with and she saw one of these things and I had her do the whole number caterpillar chart, and she worked with Target Test Prep. So I had her print up her sheets. And then these are some of the things that we did today. We did integer properties, number caterpillars, factors, multiples, finding the GCF. We did the rules of divisibility, showed you long division. We did the 36 problem, but we didn't do these other two. And this other stuff is kind of hard. So I didn't do this, but she was flying through the stuff. So, I tailor it to how people are doing. And then here's some homework that I give her, and, I drop it I always, copy and paste this and drop it into WhatsApp. I usually use WhatsApp because, well, that's just more specific to me. But anyway, so then the other thing, so I don't know why it's showing up because I copied and pasted this, but this is, like the strategies on the second day and counting the number of twos. This is what I was talking about before, like 100 factorial, how to figure out how many twos are on that entire page. So, I talk about strategies. That's what I was putting up here. Okay. For every single student, I make an error log. I can show you what that is. Like, this is something that I make everyone a tracker. And then test review is I have my students usually purchase a package of practice tests from Manhattan Prep because they have them. And then this is like test review. And I talk about that. This is someone who's doing, this is GRE. And like a lot of what I'm doing is, this is the high school teacher in me. I keep people accountable. I keep people accountable. The other end, and at the same time, I push people really hard because this is, I'm trying to make this super efficient. Another thing is I have created, like, everyone gets invited to my Google Drive, and my Google Drive has a lot of, this is where I will assign most of the math. And there, a lot of my lessons are specifically in here. They're kind of like, they help me go through it, but you have access to all that. And then other things that I have are, I have made a lot of videos of some of my lessons, and this is sort of just to make things more efficient, so that sometimes I assign people to watch a lesson that I recorded usually with another student. I don't like to, even these kind of like what we're doing now is not as interactive. I like when some of my students have been very nice to let me record them, and we put an emoji over their face or something, but I like it when it's interactive and you can get like a sense of what it, and people like watching them because this way they, I don't know, watch them on double speed if they want, but this way I can have someone do this entire lesson, and then I can work with them on the harder problems because there's the demo lesson problems that go with this one and whatever. It's just, I might be getting into too much of the details. But anyway, you can book an intercession with me. I do have a package. What I usually have people do, look, usually people work with me from anywhere from 20 to 50 hours, okay, depending on how much work you need. And what I usually tell people is, like, in the beginning, I used to sell these packages, like, hey, like a 20-hour package, a 30-hour package, all these different things. But I, over the years, realized that I prefer to just do 6 hours with someone. And then from there, talk about what I think they need, because I don't know what they need really until I see them for 6 hours, and I get to know them. You get to know me, you get to see what it's about, what it looks like. And then I can give you a more accurate, like, I don't want to oversell something that you don't need. I also want to just customize it based on your time, based on, whatever you're interested in doing. And then this way I don't, I'm trying to make more videos to make it like more efficient. But yeah, that's basically the whole shebang. Amanda's probably putting in, yeah, so you can see my GMAT GRE 6-hour intro package. But if you have any questions, just schedule a meeting with me and we can go from there. And I hope you guys you're still here and you're still listening. I don't know, it's always weird. when I do these things because I am so much more of an interactive. I don't like teaching to classes when I do this. I like one-on-one. So I'm actually talking to someone. Okay, great. I'm glad you guys are here. Thank you. I hope you liked it. And Amanda, I don't know, do you want to take over? And I don't know if there's a slide that we put up at this point or what. Because there has been in the past, but should I stop? Yeah, okay, you took over. Cool.
Yeah. I've sent Marie's profile in the chat, and you have an opportunity here to scan a QR code. But other than that, Marie, if you have anything else, thanks for hosting a great session.
Okay, great. Thank you so much. Thank you guys for attending. I'm glad you liked it. Yeah, okay. Hope you guys have a good rest of your day or evening wherever you are. Take care. Bye.
Thank you.